Hello, I would like to introduce Giancarlo Guizzardi, who talked about ontology and its implementations in new approaches to information systems design, I would say. So I would like to ask you at first, what is the biggest challenge in providing interoperability of data?
Okay, so interoperability is this problem that it's very easy to define and it's very hard to solve. Interoperability is how you maintain, so we have to put together a number of silos of information, applications, databases, and so on, models in the end, that were developed in an autonomous and concurrent way by different people in different points in space and time. And we have to guarantee that the meaning of a certain piece of data is preserved once it leaves these silos. So the problem of the interoperability is coming up with a way to harmonize different worldviews which are represented in these different silos of information. And there is no way to do that except by finding out how the reference in reality which are represented in these different data silos are related. So any information system is somehow a representation of reality, right? So it represents real entities, real events, real locations, things, real relationships, and so on. And these real things in the world are mapped to these different representations in these different silos, and we have to find out how they talk to each other.
Okay. You underlined the role of constraints in modeling, defining models. How to say whether applied so far constraints are enough? When to stop looking for new constraints?
Okay, yes. So if we take that every information system embeds a certain worldview, the role of conceptual modeling is making explicit this worldview, right? We can only solve this semantic interoperability problem if we have access to the worldview which are represented as these information systems, and we have access to this through the models. So these models, conceptual models, should be seen as contracts. So they really work as contracts telling the world what is the worldview which is embedded there. And like in any contract, constraints play a major role, right? So you include constraints in contracts to do one thing, to guarantee that the possible interpretations of the contract are the intended ones. So for example, when I do a contract to buy an apartment, I want to guarantee that there is no interoperability problem there. So the things I'm referring to, or the things I had in my mind when buying an apartment, when foreseeing the situation of buying an apartment, are the same things that the seller has in her mind. So that's why we include these constraints. And in order to include the constraints in the contract, we need to make distinctions which are domain distinctions. So we have to, for example, make a distinction between the private area of the apartment and the public area of the building, such that when I say that I'm paying this amount for an apartment of this size, this, you know, the hallways and the garage and the public areas are not included. The common areas are not included. So the constraints play this role there. So how do you know how much is enough, right? And that's the role that the simulation and this approach of model validation via visual simulation that we have, that's the role played by this technique. So what we do is, if you take the model, the contract, we generate the possible interpretations of that contract such that the user can be contrasted with the set of possible interpretations and evaluate if that reflects the set of intended interpretations. And the user would play the simulation game until he's satisfied, and he keeps doing this by including or excluding constraints. So in the end, validation is always about finding out if you have the right model, the model that really represents your conceptualization. And like in any problem of validation, you cannot be 100% sure. You can only be convinced enough.
Yeah. At some point, you just have to start trusting your model, right?
Yes. Yes, but you know, by doing the simulation and by having other people doing the simulation and by doing this problem detection techniques like the anti-patterns I mentioned in the talk, you can grow your confidence on your model.
Exactly. Okay, can you describe shortly new elements that were added to the standard UML so that you create onto UML?
Okay, so onto UML was created. So the problem we are trying to solve, if you want to have a language to model any phenomena, any set of phenomena in any given domain, you have to guarantee that the language has modeling primitives that are enough to represent all the subtle distinctions that exist in the domain. Right? This is for any domain. So the problem we were addressing there, the problem of conceptual modeling, is in the end coming up with some sort of language that is able to make justice to the distinctions that we human beings make when conceptualizing different aspects of reality. Right? And this is a problem of ontology. And what we did using a very systematic language engineering approach is that we took a foundation ontology called the UFO, and we re-engineered or we engineered a conceptual modeling language that would reflect the ontological distinctions put forth by this ontology, and that would have in its meta model grammatical rules that would reflect the axiomatization of this ontology, such that when building models in this language, you could only build models which are conformant to this ontology. So in a very practical way, we took this UFO ontology with, that has theories talking about all these different concepts in conceptual modeling, so types and taxonomic structures, part-whole relations, events, different types of relations, different types of dependence relations, these problems of identity and change, multi-level structures, and so on. So we had all these different theories in UFO, and what we did was to analyze how much traditional UML or classical UML, standard UML, would be able to capture all these different distinctions, and it turns out that UML is very incomplete. So if you take the notion of type, in reality, we have different types of types that can be applied to the same individual. So we have, for example, I'm a person necessarily in all possible situations, but I can play several different roles. So it's a different type of type. I can go through different phases. So I'm an adult man, but once I was a teenager. I'm a living person, but I will eventually not be a living person, and so on. So these are all different types of types that apply to the same individual that in a language like UML are all collapsed in one single construct, this construct of class. So technically what we did was an extension of the UML meta model with a number of OCL constraints that reflect the axiomatization of UFO. So onto UML is basically a lightweight extension of UML 2.0. So it's a UML profile, right? But now with a very complete formal semantics and a number of operational semantics of mapping onto UML to different languages.
Okay, and so after all those changes, all those additions, in what way the onto UML is better than the standard UML? Does it let us draw better models or do it faster?
Yes. Well, so judging the quality or the adequacy of the language, in order to do that, we have to look at the set of phenomena we want to model and the set of problems we want to solve, right? So the complexity of modeling or of problem solving is actually largely defined by the nature of the problem, right? So if we have a very complex problem, we have to come up with a system that can deal with that complexity. So in modeling, the system is always the user, the modeler, plus the language, right? If you have a language that is really, really simple, you are basically transferring the complexity to the user, to the modeler, right? In order to achieve the same results we have in OntoUML with a neutral language like UML or ER diagrams or with first-order logics or anything else, you need to have, the system requires a very complex complement part. So the user has to be very, very skilled and very experienced. So in OntoUML, what we are doing is taking the complexity from the user and putting in the language. So in the sense that we have all these ontological distinctions represented as primitives of the language. So the language is much more expressive than OntoUML and much more explicit in these distinctions which are made. What else? The language also, because this is unlike UML, a language that is not neutral from an ontological point of view, what happens is that you decrease the freedom of modeling choices. So for example, if you know that being a professor is a role that I play, if this is a role, being a professor is a role played by things of one single kind, in this case person, so professor is a role that can only be played by people, and I can only play this role in relation to some sort of education institution. So I need to have a relation to something else, which is an education institution and so on. And then I can cease to play this role, and this relation has a content on its own, with my employment relation, and this is created by events, this is changed by events and so on. So instead of just having this one single isolated construct of representing professor, now I have a whole cluster of constructs that behave in a really nice way, and this forms a pattern. So as a result, all different, the actual modeling primitives of OntoUML are all these different ontology patterns. So building the model is actually putting these patterns together. This helps users in building the models, as I said. So people build models faster, and they converge faster to the same models if they have the same worldview, the same conceptualization. And the results are even better or seen in a more dramatic way in the case of novice users. And we also have a number of additional tools, like tools for detecting modeling mistakes, recurrent modeling mistakes, these anti-patterns, tools for, we are working on tools for doing complexity management of large models, and this is something that can only be done due to the rich expressive of the language and the ontological semantics of the language. This would be very hard to do in an ontologically neutral language like UML.
Okay, so very shortly, you're adding, or you added the whole environment to every single element that can be used to build a model, right?
Yeah, that's the idea. The idea is making the language richer and taking everything that users would take years and years to learn, so known modeling patterns, known modeling errors, and putting in the complement of the user in the system. So the set of tools, the language, the patterns, the methodology, the anti-patterns, the computational support systems, and so on. So you put the complexity there in a way that it's systematized, standardized, such that you can shield the user from this complexity of dealing directly with the complexity of the problem, but also protecting the user from herself, because otherwise the user would make these mistakes over and over before learning how to do it.
Yeah. Okay, so thank you for the interview.
My pleasure.